Hey everyone, and welcome to today's Study Spark Explainer. I'm absolutely thrilled you're here today because we've got a really fascinating topic lined up. We're going to strip away the sleek metal and glass of the devices you use every single day and look at what is actually going on inside. So get ready as we jump right into this presentation to explore the anatomy of a machine. It's time to uncover the true brain of a computer.
Okay, let's kick things off with a quick question. What do a massive, tricked-out gaming PC and that ATM down the street actually have in common? I mean, on the outside, they look completely different, right? But the fascinating truth is that beneath those wildly different exteriors, all computing relies on the exact same foundational architecture. They both completely depend on 5 basic, fundamental components to function. Today, we're opening up that black box to see exactly what's inside.
Section 1. Inside the black box. The 5 pillars.
To really wrap our heads around this, let's use an anatomical metaphor. If we crack open a computer's case, we see it isn't just one monolithic thing. It's a team of internal organs working together. Data moves linearly through this whole system. We start over on the input side to give commands. That data travels into the central processing unit, or CPU, which actually contains 3 distinct internal components: the memory unit, the control unit, and the arithmetical and logical unit. And finally, the process data flows out to the output devices so we can actually see the results. These are the core elements that make any computer function.
Section 2. Input devices and sensors. The machine's senses.
We usually just think of keyboards and mice, but input devices act as the literal sensory organs of the computer, translating human actions and physical world data into machine language. Take a neat little device you might not use every day, for example, the light pen. It looks a lot like a regular pen, but it's a highly specialized input device. When you move the tip over a screen and press the button, a tiny photosensing element inside detects the exact screen location and sends that corresponding signal directly to the CPU. It is literally using light to draw directly into the digital world. How cool is that?
But input goes way beyond human touch. Sensors act as the machine's nerves. We have magnetic field sensors, motion detectors, sound sensors, humidity, light, and heat sensors. The absolutely crucial point here is that they just capture raw environmental data without making any judgments or decisions. They feed these real-world physical properties straight into the system for processing.
Output devices. Seeing the results.
After all that sensing and crunching numbers, output devices are how the computer talks back to us, presenting that processed data in a human-understandable form, whether that's a video on a screen, printed paper, or audio through a speaker. To really understand this, let's think about an older piece of tech, the cathode ray tube, or CRT monitor. Before we had flat LCD or LED screens, monitors used a vacuum tube. An electron beam literally shot out from a cathode, accelerated at a super high velocity, and was deflected by coils to strike a phosphorescent surface on the screen. It's honestly fascinating to think that old computer monitors were basically mini particle accelerators shooting beams of electrons just to draw images for us.
Section 3. The brain. The CPU explained.
Moving away from the senses, let's dive into the core of the system. The central processing unit is the primary brain, but it actually has 2 distinct personalities. First up, we have the control unit, or CU. Think of it as the traffic cop. It manages the entire functioning of the system, interpreting data and issuing signals to execute operations. On the flip side is the arithmetic and logical unit, or ALU. This is the calculator. It handles all mathematical operations, like addition and subtraction, plus logical decision-making, like determining if one value is greater than another. So the traffic cop directs the flow, while the calculator does the heavy lifting.
Section 4. Memory and storage wars. Short-term versus long-term.
Now, if the CPU is the brain processing thoughts, we really need to differentiate between its short-term processing space and its long-term memory. We've got RAM on one side and ROM on the other. RAM stands for Random Access Memory. It's your volatile short-term storage. It holds the data the CPU is currently processing, but here's the catch. When the power goes out, poof, all that data vanishes instantly. ROM, on the other hand, is read-only memory. It's non-volatile. Even if you pull the plug, ROM securely holds onto its data. It's absolutely vital because it contains the permanent pre-written boot-up instructions from the manufacturer that actually wake the computer up.
To put this capacity into perspective, the scale of computer memory is just mind-blowing. We start at the very baseline with a single binary bit, which is just a single cell representing a 0 or a 1. From there, we group 8 bits into a byte, and then we just keep multiplying by 1024. Kilobytes, megabytes, gigabytes,
all the way up to a massive zettabyte. The sheer mathematical leap from one tiny little bit to an enormous zettabyte is absolutely staggering when you think about how much information we can store today.
And speaking of storing massive amounts of data permanently, let's look at secondary storage. This is the real storage war, the hard disk drive, or HDD, versus the solid-state drive, the SSD. The older HDD relies on electromechanical moving parts, using positive and negative charges on spinning magnetic plates. Because it physically moves, it's slower, it's noisier, and it consumes way more power. The SSD, however, is the new generation. It uses flash-based memory with zero moving parts. It is lightning fast, highly durable, and consumes much less power. It's just a huge evolutionary leap for our digital body.
Section 5. Stages of Data Processing. The Data Life Cycle.
Bringing our anatomical journey to a close, let's zoom out a bit and look at the holistic life cycle of data from start to finish. It basically builds into a continuous cycle, from data collection and preparation to inputting it via our sensory devices, processing it in the CPU brain, outputting the results to our monitors, and finally locking it away in storage. Every single hardware component we've looked at today plays a crucial, interconnected role in bringing raw data to life and turning it into meaningful information you can actually use.
So here's something to think about. As we continue to build unbelievably fast SSDs and incredibly smart CPUs, will this basic five-pillar anatomy of input, processing, memory, control, and output ever fundamentally change? Or have we already perfected the digital body? If this explainer helped you spark an interest in how things actually work under the hood, make sure to hit subscribe for more deep dives into our StudySpark presentations. Keep learning, stay focused, and I'll catch you in the next explainer.